Hello everyone, I am Shweta. Today we see about the topic Ethernet technology, the IEEE 802.3, the backbone of modern networking. First of all, what is the Ethernet? Ethernet is a networking technology is used for wired communication alone between devices in the local area network. First, introduction to Ethernet. In this seminar, we see about the introduction of Ethernet and basics of Ethernet and its evolution and its frame structure, its types of cables and advantages, limitation, applications. Okay, first we see the basics introduction to Ethernet, the foundation of connectivity. Ethernet is standardized from as IEEE 802.3. From this version, most of the Ethernets are upgraded as another version like IEEE 802.3A, 3B, 3Z, like that. It is the most widely adopted wire LAN technology, that is the local area network technology. Ethernet is the most efficient way in LAN. It underpins most of the world's local area network. Evolutionary journey from its origin in the 1970s, Ethernet has continuously evolved, adapting to increasing demands for speed and reliability. From its origin, the Ethernet is established in 1970 as 10 Mbps speed Ethernet, but now it is up to 400 plus GPS now, and reliability means provide a stable and consistent performance compared to the wireless. Compared to wireless, it's provide a consistent and reliable data information, and it's also cost effective. Cables and switches are relatively cheap, and security, and it's works as a universality. The Ethernet is adapted for all kind of devices. There is no restrictions. In this seminar, explore the Ethernet's fundamental principle, technological advancement, its pervasive role in today's digital landscape. Basics of Ethernet. Okay, basics of Ethernet. The Ethernet operates at the data link layer and physical link layer of the OSI model. The key characteristics include, okay, OSI model means the network transferring layer, right? The OSI model has 7 layers, and this 7 layer, Ethernet puts its role at data link layer and physical link layer, and that consists what are the terminologies in Ethernet are the frame-based data transfer. Yeah, this is the main thing in Ethernet. In Ethernet, the data is transmitted through the cables in the form of frames. The frame-based data transfer. If we give the big data, the data is broken down into small frames. The frames is given with the MAC address, and thus using the MAC address, it identifies its destination device to send the data. This is the concept behind the Ethernet through the cables, and the sending data is encapsulated because of the structure of frame, and it's using the addressing. Each device has a MAC address, and it sends the data frames using those MAC address. Okay, data is encapsulated into frames for transmission. So CSMA CD. CSMA CD means carrier sends multiple access with collision detection protocol manages access to the shared medium in order of duplex interpretation. CSMA CD is nothing but is a protocol to use to avoid or overcome the collision, data collision. For example, if two devices are sending the data to each other at a time, means then there is a collision happens, right? In order to avoid that, we use this concept, the protocol CSMA by CD. In this traditional Ethernet only, but now currently we use the switches. The switches is connected with the devices, so there is no way to happen like the collision reaction. right? Then MAC address. Yeah, the MAC address is the very important one that all the systems, the computers, laptops confirm have this MAC address. Unique 48-bit media access control addresses identify devices on the network. Each device has a MAC address. The Ethernet frame uses this to know who to send the data to. Media access. Earlier Ethernet with the avoid sending at the same time. MAC addressing is okay, so data transfer. Next, topology. Traditional. What is the topology? In traditional way, we use the bus and star topology, but now we use the modern Ethernet. Predominantly uses star topology with the switches. The switches is the center server like, and all the devices is connected to this like star. This is the topology. Star topology we used in the current Ethernet. Then this is the evolution of the Ethernet speed. In the first it's established. It is in 1970 as a simple 10 Mbps Ethernet. Then it's a little bit upgraded to a faster Ethernet in 1995, and then in 1998 the faster Ethernet is also upgraded to 1 gigabit Ethernet, and then the 10 times the speed of data is increases in this year, the 10 gigabit Ethernet, and after few years it is upgraded to 100 gigabit and across 400 gigabits. It's not stopped till this. It's going upgraded. In future it may be exceed the 800 Gbps speed. Then Ethernet frame structure. I already said that the Ethernet sends the data in this form of frames, and each frames consist of 5 structures: Premble and SFT, MAC address, length type, data field, FCS, Premble and SFT. Premble is do the function of synchronization. The synchronization field allowing receiving devices to prepare for frame reception. Synchronization fields allowing receiving devices to prepare for frame reception. That is, if the sender sends the data to the receiver, and it allows this Premble allows the receiver to detect that the new frame is the arriving new frame is timingly aligned. அப்படியா கரெக்டாக அலைன் ஆயிருக்கா சென்ட் ஆனது அப்படின்றது தான் பார்க்கும். இது MAC addresses is 6 byte destination source address neatly identify sender and the receiver. Identify the MAC address is mainly for identify the sender and receiver. Then each device has a unique 48-bit MAC address. All the devices consist of this 48-bit MAC address, and then the destination MAC address ensure the frame reaches the right device also. Okay. Then the length or type. This indicates either the size of the data field or the protocol of the encapsulated data. Then data field, it actually carries the data, original data as it is, and minimum size of this, and minimum size is 46 bits, maximum size 1500. Typically carries a higher layer package, carries the actual data. Then FCS CS. FCS means frame check sequence using the protocol called cyclic redundancy check, that is a CRC. This ensures the error detection and uses a cyclic redundancy check. Frame check sequence for error detection ensuring data integrity during transmission. Uses a cyclic redundancy check to ensure the frame was not corrupted during transmission. If there is any errors occurs or corruption occurs, means the frame is discarded or else may be retransmitted to the system. It's only to check the data before it sends. Then we see the types of Ethernet cables. The Ethernet is nothing but connecting through the wired community, wired medium-like cables. The types of Ethernet cables are three: the unshielded twisted pair and fiber optic and coaxial. The unshielded twisted pair is the most popular and commonly used Ethernet cables. In this picture, we see that there is a two wires are twisted to each other and it's unshielded. They twisted together, so it's called unshielded twisted pair. Most commonly categories like easily array categories. They consist of many categories like Cat IE, Cat 6, Cat 6A, Cat 7. Define performance and maximum speed. It's enabled for mostly maximum speed. Okay. Next, the fiber optic cable. In the name itself, the fiber optic means that the data is sending through light energy, right? The fiber optic cable is not different from other cables because of this. It supports the long distance data communication for high speed. Even also high speed, it supports a long distance communication immune to EMI, used in backbones and data centers. Used in backbones and data centers. And then coaxial cables used in yearly Ethernet 10 basis. Coaxial cable used in yearly Ethernet are largely replaced by twisted pair and fiber. Yeah, this is not now. Mostly this is not used. It is outdated one, the coaxial. Instead of this, we also prefer these both cables. So this is an outdated cable. The advantages of Ethernet: it is a high speed and bandwidth because it supports from 10 Mbps to 400 Gbps. So it's highly adaptable to our data speed with upgrading itself like high speed and bandwidth, and reliability and stability. Proven technology with robust error detection mechanisms and stable performance, especially in wired setups. Reliability and stability. Why means the frame structure ensure the data encapsulation. So it is the data is availability, integrity, and also it said that its reliability, right? Then cost effectiveness. The cables are relatively cheap, right? So it's a cost effective, inexpensive to implement and design the setup. Then widespread interoperability. Widespread interoperability. It can engage with any other devices or any OSs, any type of devices, right? The universal standard ensure the compatibility across devices and vendors, simplifying network design. Then security. Compared to wireless, wired communications always best to security. Wired connections offer inherent security advantages over wireless, as physical access is required for interception. Limitations and challenges. Limitations and challenges. Physical cabling. Limitations and challenges. Physical cabling constraint. In this picture, it's clear that the messy lookup of this cables because of its long distance or many devices are connected means there's a lot of cables are required. Then it's very complex to design and organize, right? And if many cables are buying means also it's affected cost, right? It's become very rich. It's become very expensive, right? Physical cabling constraints and distance limitation. Wire cables are limited to distance, but using fiber optics it is achieved, but it is also considered as very cost effective and for very cost expensive. Collision damage. Order shared media, Ethernet suffered from collisions, reducing efficiency. Modern switch Ethernet largely eliminate this. Then single point of failure. All the devices are connected in a single center switch. If there is any failure in switch, means that the total network drop out. General switch in star topology can be a single point of failure if not properly redundant. Then power consumption. Yeah, right. The cables connected the power pins to access our net data, but in this way, if we use high speed Ethernet components means they consume a high power consumption. High power consumption consume significant power in large scale deployments. Then real life application. Real life application we use in data centers for high speed Ethernet and backbone for server to server connection. And in enterprises and campus networks we use it for workstation server connection and other devices connections. And industrial control. In industries we use it for enabling a reliable communication. A reliable communication between the industrial automation devices in manufacturing. And home networks providing a stable and fast internet access for gaming, streaming, connected smart home devices. The future of Ethernet. Continued speed increases and power over the Ethernet and time-sensitive networking. Then we conclude this seminar. This conclusion, Ethernet evolved from 10 Mbps to 400 Mbps. Reliable, it's scalable, it's cost effective, it's backbone of LAN, enterprises, data centers, cloud, and future it becomes ultra fast, secure, energy efficient networking. It's access in this future. I think almost covered all the topics. Thank you for listening and watching. Thank you.